Hi everyone. So in this video, I'd like to look at how we can find the period of sinusoidal functions from graphs. Okay, so how do we find the period? What's called a period of sinusoidal functions from graphs. So before we begin, we need to know what a period is, right? So period. What is the definition of period when we talk about them in these sine functions, right? Sinusoidal functions. So a period is basically the horizontal distance from from distance, I'll put it this way, of consecutive maximum values, or minimum values. Okay, that's it. So when we talk about the period of a sinusoidal function, we're looking at the horizontal, not the vertical. Okay, I know that we only focused on the vertical coordinates when we looked at the midline and we looked at the amplitudes, correct? So, but in the period, we're focusing on the horizontal coordinates. Okay, the horizontal distance of consecutive maximum values or minimum values. Okay, so when we look at this problem, here we have another sinusoidal function example, and the period of this function is going to be the horizontal distance from this max here to that max, okay, or from a minimum to a consecutive minimum. Now here we don't have the graph of the other minimum values, just one minimum, two maximums. And they give us the coordinates for the minimum here, and they give us the coordinates of the midline here. So then how are we going to find the distance of two consecutive minimum or maximum values? Well, you have to understand that when we are given a minimum value, okay, let me rephrase it this way. So we know that, let me just kind of draw it for you. So the period looks like this. So if we have let's say I have a sinusoidal function, maybe it looks like this, okay, and it is continuous. I'm sorry about the horrible drawing, okay? So from here to here, this horizontal distance, that is a period. Okay, that's one period. That's one period. Or this distance from here to here. That is the same distance, horizontal distance, okay? And we can keep going, right? That could be another distance from here to here, etc., etc. That's one period. Well, if that's the case, then if you look at this again, and this is going to be another period right here, correct? This distance over here. If that's the case, then how can we use a point on the midline? Let me draw the midline here. Let's say that is the midline. That's the midline. And if we're given a point on the midline, let's say we're given the point right here, correct? How can we find the period given a minimum, just one minimum value, just a minimum value and the midline? Well, I want you to look at this. If it's one period from minimum to minimum, then do you agree that it's half a period from minimum to maximum? Okay, this here is then half a period. That's 1/2 here. This distance is half of a full period, correct? So from minimum to max, and I just lost it again. Okay, so from minimum to max is one period. We just got it back. So from minimum to maximum is going to be a half a period. So then from a minimum, let me change the color, from a minimum point to a midline point, this distance right here, then that's going to be half of half, which is 1/4. This distance from minimum to a midline, to the nearest midline, right? It could be from here to here, or it could be from here to here. It doesn't matter. Okay, this distance from midline to from minimum to midline is a quarter of a period. So from minimum to midline, okay, is 1/4 of a period. In that case, then, if we can just find this distance from minimum point to midline, all we have to do is multiply it by 4 to get a full period. So let's do it. Here it is. We're using now the horizontal distances, correct? So we have to find the distance from 1.2 to 5.2, right? The x values. We're using the x's now because we're looking at horizontal, not vertical. So let's find it. So it's going to be 5.2 minus 1.2. Remember, you subtract the find total distance, and that's going to give us 4. And that's the distance right here. That is the horizontal distance from minimum to midline. This is 1/4 of a period. 4 is 1/4 of a period. So then I have to just multiply the 4 by 4, right? That's going to give me 16, which is equal to the full period. Okay. So 16 is going to be my period for this function. So this distance from here to here is only 1/4 of a full period, right? So I have to multiply by 4 to get the full period. So let's go and do it. So 4 times 4 is 16. Let's check, and that is correct. Okay? All right, next question. Here, they gave us 2 points, and both points are on the midline. Okay, both points are on the midline. So again, let's take a look. If both points are on the midline, then how do I find the period? Well, when we're talking about points on the midline, remember, take a look. To get one, to go from maximum to maximum, it takes, you're basically going through the sine function and finishing it where you started. So you start up here, come all the way down, you go all the way back up, and now you just finished where you started at the maximums, correct? Likewise in the minimum. You start at the minimum, you go all the way up to the top, then you come back all the way down, and you finish at the minimum again. That's one full period. So if we're going to start from this midpoint here, then we have to go all the way through, go down, go back up, and then finish again at that same spot that we started with, downward, right? Going down on the minimum, on the midline. So we're going downward on the midline here, not upward. So then from here to here is one full period, but from here to here is only half a period. Okay, and again we have to take the x coordinates. So it's 1/2 pi and 5/4 pi. So let's subtract 5/4 pi minus 1/2 pi. So it's 5/4 pi, 5/4 pi minus 1/2 pi, right? And that's gonna, we need common denominators here. So it's 5/4 pi minus, what is this? 2/4 pi. And then we can just subtract the numerators, so it's going to be 3/4 pi. But remember, this is only half a period. This represents only half, right? We're going from the midline downward, down to the minimum, and then up on the midline again, not down. That's only half. We've only finished half of a period. We got to do the other half. So now we got to multiply it by 2. Got to multiply this thing by 2. That's going to give us 6/4 pi. And if we want to reduce this, that's going to reduce to 3/2 pi. Okay, so either one, this is correct or that's correct. This is the reduced, this is the non-reduced. So 3/2 pi is our final answer. Okay, so 3/2 pi. Okay, guys? All right, let's try to do maybe one or two more. Here we are given minimum point and a maximum point, correct? And that is only half, right? We just discussed it. From minimum to maximum is only going to be half of a period. So if we take the x-coordinates, let's see. It's from negative 10.4 to negative 3.6. Negative 10.4, let me erase this. So negative 10.4 minus, and we could do it either way, right? It's going to be minus 3.4 minus negative 3.4 minus negative 3.4, and that's going to be plus plus here. It's going to be plus plus, right? So this will come out to, I believe, negative 7, but it's distance, so we're talking about the absolute value, which is going to give us 7. So if we go back here, so the horizontal distance, oops, I think I got these coordinates wrong. Yeah, should have been 3.6, sorry about that. So let me just do that again. Just clean it up a little bit, that should be 3.6. So 6 minus a negative 3.6, right? Yes. Okay. And that's going to be, it's going to be plus plus here, of course. Keep change change, and we're going to get negative 6.8. 6.8. Okay. Since we're talking about distance, so we're going to take the absolute value of this number, and that gives us 6.8. So 6.8 is the horizontal distance from the minimum to the maximum. That is the horizontal distance, but we're only talking about half of the period here, so we have to double that value to get the full period. So twice 6.8 gives us 13.6. And that is our total period for this particular function. So let's type it in. Six, and that is correct. Okay, one more real quickly. Here we're given a point on the midline, and we're given the minimum value, which is, now we know, is 1/4. It's 1/4 of the total period, right? This would be the total period from minimum to minimum. From maximum to minimum, or minimum to maximum, is a half a period, and then from the midline to the minimum is a 1/4. So let's find the distance, the horizontal distance from midline to the minimum, and then we can multiply that by 4. So we have 2/3 pi and 4/3 pi. So we have 2/3 pi minus 4/3 pi. And that gives us negative 2/3 pi. But again, it is distance. So we just take the absolute value, which is 2/3 pi. This is now 1/4 of the period because it goes from midline to minimum, right? So now we're going to multiply that by 4, and that gives us